All right, class, next section, 6.5, prove triangles similar by SSS and SAS, side, 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 and side angle side. So the first one, not to be confused with our congruence theorems, these are proving our triangles similar, not congruent. So side, side, side similarity theorem is if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So all three side lengths must be proportional to the second triangle side lengths, and then the triangles will be similar. The side angle side similarity theorem is if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar. Remember, included means in between, so the angle must be in between the two sides that are proportional. So if we use the SSS similarity theorem, or side-side-side similarity theorem, is either triangle RST or triangle XYZ similar to triangle ABC? So we're looking at ABC and seeing if either RST or XYZ are similar to it. So we're picking out the one that's similar, if any. So using the side, 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 we need to check all of our proportions. So we want to compare triangle ABC and RST by finding the ratios of the corresponding side lengths. So if we look at RST and ABC, we've got ABC has sides of 3, 4, and 5. RST has sides of 3, 4, and 4. So we can match up 3 over 3, matching up the shortest side first, 3 over 3. That simplifies to 1. 4 over 4. That simplifies to 1. But then what we're left over with is we would have a 5 over 4, which is just 5 over 4. So they are not the same. Not similar. So then we want to compare the other triangle, XYZ. So I look at my smallest side length on ABC, which is 3. Compare that to the smallest side length on XYZ, which is 6. Simplifies to 1/2. Then our middle side length on ABC is 4. Middle side length on XYZ is 8. That simplifies to 1/2. Then our longest side length in ABC is 5. Longest side length in XYZ is 10. That simplifies to 1/2. So XYZ is our similar triangle to ABC. So triangle ABC is similar to triangle XYZ. So whenever you're matching up side lengths to see if they're similar or not, it's good to start with the smallest side lengths and then work your way up, or start with the largest, the longest, and work your way down. And then you can set up those proportions, but also matching up your vertices is good. So that can be a good visual, is looking for the smallest sides, the middle side, and the longest side. Okay, so we're using the side-side-side similarity theorem again, and we're going to find the value of x that makes triangle ABC similar to triangle DEF. So we're going to use the similarity statement that they give us to match up our sides. So AB with DE, BC, DF, and CA with FD. Now to set this up and find our value of x, we only need to match up two sets of sides, and we'll be able to solve for x. So if I look at, let's use AB and DE, that would be 27 over 18, or 18 over 27. That's going to be equal to, and now we'll just pick one of the sets of sides with x. I'll use CA and FD. So 8x plus 1 over 22. Now we just need to cross multiply. 27, so we'll just write this out again. We've got 18 times 8x plus 1 now, equal to 27 times 22. So we'll distribute the 18. 18 times 8x is 144x plus 18. And then 27 times 22 gives us 594. Next, we want to work to get x by itself, so we'll subtract 18 from 594. It's 576. And that's equal to 144x. Divide by 144. X equals 4. So we could have used BC and EF with 15 over 2x plus, or 15 over 2 times x plus 1 instead of 8x plus 1 over 22 if we wanted, and we still would come out with x equals 4. We could also set it up with BC over EF and CA over FD. And even with both of those x's there, we could still figure it out. We would just have to do some, we would end up with an x squared in there and find a square root, something like that, but we would still come up with x equals 4. So you just have to pick two of the three. All right, now let's practice the SAS similarity theorem. Remember I said that the angle has to be in between the two sides, included between the two sides. Our two sides form that angle. So we have PR matches up with TV, and QR with UV. And you can see those two sides form that angle, those congruent angles. So we just need to set up our proportions and cross multiply. So if I set up 3x plus 4 over 20, that'll be equal to 30 over 24. So we can cross multiply there. 30 times 20 and 3x plus 4 times 24. 24 times 3x plus 4. We'll distribute that 24 into the parentheses, and 20 times 30. So distributing 24 times 3x gives us 72x. And 24 times 4 gives us 96, so plus 96. 20 times 30 is 600. work to get x by itself, so subtract 96 on both sides. We'll get 72x equals 504. Divide by 72 for the last step. And x equals 7. So pay close attention to what the SAS similarity theorem looks like, where the angle is in between those two sides that we're using. Because there is no angle side angle like there was in the congruent triangles. For the similarity, for similar triangles, we only are using angle, like we learned in the last section, and then side, angle, side. And the sides aren't equal, they're proportional. Okay, so example number 4, we want to tell what method we would use to show that the triangles are similar and explain our reasoning. So we can see our two triangles. We've got our sides here. So we need to know what sides would match up with what sides, which ones are corresponding with which ones. If we look at along PQ and ST, we don't have any numbers. We don't know any of the sides. So these are actually our, those are corresponding sides. So if I redrew this, I would have, I could have my triangles set up like this. I would have P, Q, R, and then I'd have, this would also be R out there, S, and T up there. So if it helps to kind of separate your triangles, redraw them, you can get a better idea maybe of where, what things would match up with what. We also notice we've got vertical angles here, so we've still got to use our original image to help us out. So we've got vertical angles, so we know those two angles are congruent. So we know R is congruent with R, and that makes sense, right? And really it's TRS and PRQ, but when we've got them separated like these two triangles, it's just R there. QR we know is 9. PR is 18. RS is 12. And TR is 24. So now it's a little easier to see which ones match up, which ones correspond. So we can say 9 over 12, which simplifies to 3 over 4. And the longer sides, so these are our shorter sides. Remember, start with shorter and then go longer. Our longer sides are 18 over 24, which simplifies to 3 over 4 as well, 6 being our greatest common factor there. So the corresponding side lengths are proportional. And the included angles, PRQ and TRS, are congruent. We saw that they're vertical angles. So we have these two sets of sides are proportional, and our included angle is congruent because they're vertical. Maybe make a note there, we've still got vertical angles working for us. Vertical angles, not verticals. Vertical angles our sides are all proportional. So we're able to show them similar by side angle side. Our reasoning was, like I said, we've got proportional side lengths and the included angles are congruent. Last two examples explain how to show JKL is similar to LKM and work to show our work to support our reason. So we've got JKL is our triangle on the left and LKM the triangle on the right. So we want to show that they are similar. Good idea to draw them out or separate them. Maybe it'll just be easier to see everything. So I'll just redraw these. That is J, K, L. And then we've also got LKM. So there's our two triangles. Make sure we remember which ones are which. But if we look carefully at the picture, we can probably tell that our green triangle in our original picture, our green triangle is in a different position than our red triangle. If we look at the red triangle, 28 is our shortest side, but in our green triangle, 28 is our middle length side. So we need to match up our little sides with our middle side and our middle sides and our bigger sides. So match up little with little, middle with middle, and big with big. So our little sides, let's do that one first. We've got shortest side in the red is 28. Shortest side on the green is 16. Simplifies down to, let's see, 4 is our greatest common factor, so 7 over 4. Then our middle sides in the red triangle is 49. The green triangle is 28. Greatest common factor is 7. 49 divided by 7 is 7. 28 divided by 7 is 4. So we're looking good so far. Then our longest lengths are big sides, 56 in the red triangle and 32 in the green. Our greatest common factor here would be 8. So 56 divided by 8 is 7. 32 divided by 8 is 4. So we're able to show that these triangles are similar by side, side, side. Able to show all sides proportional, so triangles are similar. Then last example, explain how to show SRT is similar to P and Q and show our work. So we can see that we have some right angles here. So we know that those angles are congruent. So we'll use those, look at the sides on either side of them, see if we can use SAS. So if we look at our side on the left, SR, that's going to correspond with PN, and RT will match up with NQ. So when we set up our proportions, we can say 24 over 18, or 18 over 24. I'm actually going to do that, keep my smaller number on top. I like to have the smaller number on top. So 18 over 24. Our greatest common factor would be 6, so 18 divided by 6 is 3, and 24 divided by 6 is 4. And then our other proportion would be 21 over 28. Greatest common factor here is 7. 21 divided by 7 is 3. 28 divided by 7 is 4. So we're able to show that our two sets of sides are proportional, and we have a congruent angle in between those two sides, so the triangles are similar by SAS. That is it on the notes for today. Make sure you do your 6.5 homework.